Good afternoon, everyone. Let's get started. See what we were doing last time. I have some stuff to... No, those are all untracked. All right, so let's see. I had a bunch of to-do stuff. Don't want to do that one. Don't want to do that one. Switch not unconditional to a set and do the difference. Don't really even remember what that one even means. And that's to modify the final successor if one exists. Oh, I'm still not sold on whether or not that's actually the thing to do. Because I think it's possible for successors to not be. Maybe what we need to do is figure out what's going on with sorting the nodes. Actually, no, maybe we should start with the nodes. I was trying not to do this, but I think the smartest thing right now would be to do some refactoring of these nodes. So there's in this paper somewhere around here, yeah, so they've got the different nodes that they do, and I kind of implemented these in a particular way, and I don't really like the way I did it. So I think maybe fixing that would be the first thing that we should do today, and hopefully not break everything completely. Good thing, I guess, is that it's all in my Git, so yeah, I can at least revert if I fuck it up completely. So first thing that I think I want to do is I want to add a type here that lets me know what it is, so I can do this without having to check is instance all the time. And I don't know if I want this children thing anymore. I also want to get rid of the AST thing. I don't ever use that. There's zero need. Like, I don't know. I thought maybe I was going to come back to it and actually need the AST in here, but it doesn't really seem like I do. I also don't really want a header anymore. On sequence node. What I am going to do is put type here and put sequence. Because really I want this to just be a sequence of nodes. It doesn't really have to have a special header. So this I'm gonna I'm gonna change this to nodes. Actually, I kind of want this to be a deck. I did a deck up here, and the reason why I did that was so I could do this easier. But it doesn't seem like I ever actually append left. Let's get rid of this until I actually need it. I'm just completely breaking everything now. Get rid of AST here. I think I want to do something as well that's something like, if I bring in nodes here, which has to be a list, I kind of want to say, like, if go through the elements, and if there's a sequence in the list, then expand it out. Although, I'll just leave it like that for now. I do wonder if I should sort these, but so I don't need that. So for condition nodes, we need a condition, and I'm going to do a true, a false. I don't know if that's actually a bool or if it's should be a func decal or something. There we go. Take that out. I don't think I need it. Let's do that. And say, because I want this one to have an actual start, which will be where the condition is, I think. Or do I want it to be... Oh, damn. Of course, I just now think of what I would use the AST parameter for that I just took off of these. So I think I will leave that on for now. Okay, so we put AST back. So what I wanted to do then was, I think it's comp. No, less than or equal than. Do you have to implement all of them? And here I want to say if or self.ast.reaching conditions other self is none. All right, got to make that smaller. So what happens here is this way with less than, doing less than like this, we can actually sort them based on whether or not they can reach each other. And if we do a less than like this, then this will tell us if there's a reaching condition between, if self should be above other. Less than or equal to now is going to say there's either a path from self to other, or there's not a path from other to self, which means that they are independent of each other. Which I don't know if that'll actually come up, but I just want to make sure that I have it. And then we can do the same thing with greater than. And okay. And then, did I do an equal? I don't think I did an equal. Oh. I have that on sequence, which is weird. And then we can do a return true if self dot type equals other dot type, although this is kind of already covered. And dot start equals other dot start. Isn't there a not equal to? Yeah. We'll go ahead and implement that too. And let's just say start doesn't equal other dot start. Okay, so we got all that now. So our condition then, we have our condition, we have our start, we have our true and our false, which I believe is what we want. And then loop needs a type, needs a continuation condition, and then a body in B. Which I think should always basically be a sequence. Because a sequence can then just contain a condition node, and that just makes things a lot easier. So we have we've got that. Oops, let me fix these. All right. So the medium level IL AST else node. I think we still need this. we'll do that. Do we need address? What is address used for? Oh, it's probably used over here, isn't it? Yeah. We need the address. We don't actually need this. Do we need the start? Oh, we need it. We were doing it there. We probably do need start because, yeah, the because the IL you can have two different. You can have multiple IL instructions, and actually, the we might potentially have a condition node that's in the middle of a single instruction. So we don't want to ignore that. Okay, so let's keep the address. Let's add one here too. I think I want to sort here, so I'm going to add this for now. Do I need this address? Because it has an address that it's going to get from here. I want to do it here. No, up here. Honestly, I could possibly just inherit from list here. And then it could just have its own values, but let's do it like this. Let's do this too. You pop an index. All right. And then property. I'm gonna break everything. It's gonna be awesome. I can potentially get rid of this now that I'm doing the condition thing with the bools. Might want to look into that. The break node doesn't really need a basic block. I'm gonna just insert this as its own block or node. Do an address though. All right, and then loop node, here we go. So loop, medium level layout, basic block. Don't really know what I was doing with that. This is gonna be a loop. And we're gonna do loop type here. All right. Didn't actually ever use this, so let's get rid of that. Don't know what this is. Want to move this to, yeah, no, that needs to be a default, so it's going to be the end thing. So condition will say equals bool. I really need to figure out how to do this without a all right, so that's always going to be true if by default. So then what do I need? I need body equals medium level IL AST sequence node. Loop type, we got Then we've got the condition. We can change the condition. And then, hey, I am using the famous No More Go-Tos paper. I'm going to add a 4 one because I want to do a 4 eventually. Even though they don't. Sure, let me grab you a link for that. Come over here and put it in chat. There you go. All right. So we have body, the AST's there, condition, loop type, loop type, condition, body, AST's gets passed in there. Okay, cool. I think we were done with that one. And then the switch node. Switch needs to be a condition. Don't think I need to change much on this one. Haven't done much with switch statements lately. Oh yeah, plenty of people have made this into code before me. In fact, I'm pretty sure there's a C++ version of this based on probably Mixema or Remil that somebody at my company wrote a while back. I don't remember exactly when. But yeah, I think that one takes binary code, lifts it to LLVM, and then does performs the same algorithm stuff on LLVM IL. All right, and a basic block node. Should be pretty easy. We're just going to take that out. Oh yeah, I think I was talking to you in chat on Murmus's stream when he was fuzzing. And the name looks familiar. All right. Yeah, I think he's still running it. I can't remember if he runs it when he's not streaming, but I think he does. I'm gonna just take this out and say start equals self.start. Okay. So we've completely rewritten this, which means that everything is going to be broken over here. So that's going to be real fun to try and fix. Let's. First figure out. I think I want to redo regions as well, but I will get to that. AFL code is also not the best organized code. I would love to refactor it at some point and rewrite it. All right. So maybe. All right, reaching conditions. Come in here, do your stack. Not doing anything with nodes here. I don't really need. What do I have? Oh, reaching constraints. It's really easy to make a fuzzer. You just take dev random and pipe it into whatever you're doing. It really depends on what you're trying to fuzz, honestly. There's a bunch of different ways to write fuzzers as well. You can do generative, mutative, you can do a combination of both. Is it going to have coverage-based feedback? Is it going to just be like a dumb fuzzer? Because sometimes you don't really need coverage. Like, what are you going to, how are you going to determine your coverage? There's all sorts of stuff. Brandon Falk's streams are really good for fuzzing stuff. He's doing a lot of emulation stuff, I think, right now. And I think he streams implementing some of the emulator and the fuzzing stuff. So I never catch his streams, but you know, they look really good. Okay, where am I? Generate dominated. I don't think I need this anymore because there's PostDominators. So I might get rid of that too. Find regions. Okay. Back edge node isn't going to be the root or region. I guess that's true, maybe. Let's see, is switch false? That turns it to is switch is true. Do I even need a regions thing? I don't even know if I need that. I should just create the regions as they are. Just use sequence blocks and stuff for regions, because that's basically what they are. Oh, maybe that'll clean some of this code up. And let's do something like this. make this a little nicer looking too. Get rid of his switch is true. We'll figure that out. Once again, places. All right. So what I want to do is a bitpick. No, I need to do constraint visitor maybe? No, condition visitor. Yeah. Don't take anything, just simplify. There we go. That'll turn that into oh wait, no, this is okay. I had missed that before. The switch condition needed to be a forgotten the word. Did I bring my? No, I missed my dosage of Adderall for the afternoon, so I'm a little out of it. Let's see. Yeah, so I forgot to switch the switch statement to Z3's condition instead of constraint instead of a medium level IL's expression. So that needed to happen. And now we can say current node. I don't know if I actually added that type thing to it though. Yeah. Yeah, I don't think I need else statements anymore or else nodes anymore because I can easily negate the condition in the condition node now if I only have a false branch. So that's cool at least. All right, so switch statement, we have everything that we need for that. All right. I'm gonna try switching this to bb.preDominators. Oh no, PostDominators. Can't remember what a dominance frontier is. Let's look that one up real quick. I want to make sure I've got the right thing. Dominance frontier are the just after, immediate successors. Okay. So the dominance frontier is everything immediately before you, and the post dominance is immediately after. Wait. Okay, no, that's something completely different. The dominance frontier is things immediately everything that's not you that is immediately touched by your dominator. So for B, F is its dominance frontier because it's on the same level. That's interesting. So this is the post-dominator tree. And it's still not the same level. It's just anything that's immediately before. Okay. So that's not the one I want. I want post-dominance. No. Yeah, post dominators. I want everything that it does. Now I'm getting myself confused. Let me go double check this real quick. Actually, no, this is not what I want. It's not dominators either, it's not what I want. Yeah, because it only dominates itself because it's the first one. Why is that a Dominator tree child? It's not immediately dominated. I think this is not what I want. I think what I want is I think I want everything that has BB as the first thing in reaching conditions. So let's rewrite this. Hang on. Yeah, I want reaching conditions. Let's do this in two things, I guess. So I want to get basic PR in self dot function dot basic blocks if BBPR in self dot reaching conditions. So then I want to change this to just being, I don't want to do a region anymore. I just want to do this. No, it's not loop. So then we get the reaching constraints from there to R. And what am I doing here? Let's comment this because I don't want to try and figure this out every single time. This is a condition if a reaching constraint exists and B, there's no reaching constraints between another region and the subregion. Or no, any is none. If any. Why is it any instead of all? Because I feel like this has to do with the fact that things can be reached by this block, but it might also be reached by another block. I want to say I feel like this should be all. I'll leave it for now. And at least one other region can't reach it. And this should be this is going to be just a sequence at this point then, I think, because it's acyclic. Nope, I don't know where I just went. Okay. And this should already be a loop. And current node dot type doesn't equal switch. Let's just do this. All right, to remove. It's going to remove the subregion. While to remove, oh wait, and then we need to sort this up here too. We shouldn't have to do anything more here because oh wait, no, these are actually basic blocks, so we do need to or actually, why don't we and that should allow them to sort for themselves because this should have, if I'm not mistaken, although maybe it's messed up. Yeah, it's a node. So it has all of its comparisons and will determine where it goes. Does not have a start. Let's go ahead and say Do all the other ones have a start? Yeah, they've all got starts. Actually, I don't think I need the none, so I don't need that one. You've got to start, you've got to start. You have a start. This is not going to work anymore. It's going to also need an address. And this is going to be there we go. That looks a little bit better. All right, got that. That's also a long line. Actually, I should probably just use black and have it fix some of these for me. Although it probably, yeah, it found some errors and stuff, I think. Okay. We got our address. Come down here. We'll convert this to a region to a node, condition node. All right, new node is not none. If its type isn't switch or R is not in cases, then append the new node. Nothing should be outside of cases when it's a switch, but yeah, we'll see. Actually, I'm just going to say this. Because switch nodes don't have an append, as far as I know at this point. All right, to remove list subregion. This we have to change around a little bit, I think. Region.type equals sequence. It's a condition, then to remove. Actually, subregion shouldn't be a condition. Elif, it's a loop. To remove equals subregion. Wait, no. Subregion dot loop body dot nodes. Else I'm gonna raise a type error here. Say I don't know why I got a type subregion. All right, so while to remove, we pop. Here's where we. Wait, isn't it medium level IL basic block node and medium level IL AST? Yeah, that would have never worked. Maybe that's why it wasn't working for some certain stuff. All right, so if sub.type is a sequence, then to remove plus equals sub.nodes. Actually, no, I do want to do this because it would have been basic blocks earlier, and I need like it to retain loops and things like that, so wait, do I actually use this? Oh no, to remove. Yes, okay, so I'm going through and finding them. And then what I'm gonna do is remove the first thing from the possible region. Oh, I see what I was doing. I was removing only the particular node that I had gotten to. And I added a node earlier that is just this, so okay, that makes sense. All right, so then possible region dot remove sub dot nodes 0 dot block Oh no, I don't know what that is. Actually, no, there's nothing to remove, so it'll just go to sub.nodes. And then if is instance, no, I don't need that, sub.type equals loop to remove plus equals dot append. Wait, no. Sub dot loop body dot, wait, did I name it loop body or body? I already named it body. Gotta fix that up there. Body dot nodes. I think that's the only place I put it. Yeah. Okay. I don't think that I can have a, yeah, subregion would have just been a condition or a sequence. So subregion is just going to be right there. So then I can say sub.type equals block. Then here we can do possible region.remove sub.block. I can put that up here. All right, I think that made this a way more, way less complicated. And then I can delete the region, and then nodes, let's see, are in regions. Okay, so that's just a node, because I made all of them these blocks. Did I add leave the equal on basic block? I did not. Can I put that back? No. I forgot that I'm gonna go grab that back. Wait, where's the... And there's supposed to be a button that just like lets me put this over here. Ah, fine, I'll just copy it and paste it. Because I wanted to check this. All right, there we go. If is switch, okay. Nodes append to the region. I guess we could have a switch statement. What's going on with that though? Oh yes, so what we want to do then is make a if current node dot type equals switch, then what we want to do is current node equals medium level ILAST sequence node that is self BB. No, I don't do that anymore. It just takes nodes now, right? I don't know why it's not giving me my information. Nodes list. Okay. So this is going to be okay, if it's not a loop, then it gets this one. Okay, then just append the node for the loop can type. Okay, so here nodes is going to have nothing. Actually, should be this because it's a sequence. So we start with BB. And we don't need to do this. And we don't need to do this. We'll just do region equals current node. And here we're going to append current node and then pass in nodes. And now it's a sequence with the basic block that has the switch at the end, followed by the switch statement. Which is the order that they should be in anyways. All right, that should get us everything for finding regions for acyclic. Let's see, our possible region is going to be the same thing, I believe. Sort of. Or actually, the possible region, yes. I think the possible region is going to be do I even use possible region in this section? What is this? I copied and pasted that without actually doing anything with it. Can get rid of that. Why? Yeah. Yeah, we're gonna have to redo all of that. Finding a lot of stuff that's probably bugs. That is explaining why some of that stuff was showing up earlier. Okay, and it looks like I'm not even using possible regions in here. Yeah, I don't think I am. So I'm just gonna get rid of that. All right, so now we're into how the loop actually works. Latching nodes. Here's our loop slice. Original section. Get rid of this. All right, original successor nodes. We did this, we did that. That actually is supposed to use dominators. Hang on a second. Let's see. Let's look at our paper real quick. What was that algorithm? So when a successor node is identified as a loop node, its immediate successors that are not currently loop nodes are added to the set of successor nodes. Okay, yes, dominated. Okay, so I definitely want to be using dominator there. So BB. I wonder if I could do successor and PostDominators there, but BB in successor.dominators and successor.immediate-dominator in loop nodes. Although, can successor have multiple? Oh, it's, what is it? Immediate dominator. Oh, IOut basic block. Oh shit. So the immediate dominator is not necessarily the thing. So what I want then is dominance frontier, I think. Or this might be the wrong one. I need post dominance frontier. Nope. Incoming edges. That's what I want. Does it have to be all of them or just one? Iteratively extends the current set of loop nodes by looking for successor nodes that have all their immediate predecessors in the loop and are dominated by the head. And all immediate successors. Oh, predecessors, I think. Immediate predecessors. in loop nodes for loop nodes as a set. That's good. Contains is good for that. For immediate predecessor in let's do this. Incoming.source. Incoming in incoming in successor dot outgoing, oh no, incoming edges. Okay, so add a successor to the loop if both hold true. A, the successor is dominated by the start of the loop, and B, the successor's immediate predecessors are all in the loop. That probably fixes some problems right there. That probably fixes several issues that I was having with some of the loop stuff. Yeah. Glad I reread that. Okay. All right. For our in loop nodes. Why don't I just remove them from loop nodes? Subregion dot type doesn't equal loop. Now, why am I not doing that one thing here? Whatever. And we don't need that. New node. Node. Oh, I see why. I want to do a set here too. Wait, what does it matter if it's a looper? Don't need that. I don't think I need any of that down there. I don't think I need to check for a loop. It just doesn't matter. think I just do this. If it has a condition, then I create a new condition node with that as the subregion. But otherwise, I might need this now since I don't have like a header or whatever. I can't remember. No, it'll be fine. Okay. BB is R. That doesn't make any. This doesn't make any sense. Oh, if it's not in the region, then do this. This is for doing the region. I see now. If it's not in the region, then we come down here and do this. But this looks basically exactly the same. So I don't really understand what the hell is happening. Is it possible to get things that are in the loop that haven't been subregioned already? Because I don't think that's actually the case. I feel like everything should basically be in a... Although I guess maybe the back edge stuff wouldn't. Because if there's something with a back edge, then I don't make a region with it, which makes sense. Like, it's definitely not going to be the head of a region. So I guess I do need to keep this region constraint. Yet, if it's not none, then I create a new node. This is the condition, this is the address, and the true is this. But I don't want that. I want to make this a medium level IL AST basic block. Otherwise, we just make a medium level IL basic block. I don't think that's ever actually going to happen, though. There we go. Oh. Let's see. So that didn't work. This needs to be self. And this should be AST basic block. What's the issue? Oh, comma. All right. successor and successor nodes. The break node reaching constraint. That's an issue. Successor and successor nodes. What am I doing with this? I'm adding them to the nodes, which then gets added to the region, the loop region, which means that all of my successor nodes get added to the loop when they're not supposed to. Wait, no, I see what it's doing. It's doing the break. Okay. This doesn't really make any sense. DB-1 address? That's not right. This should be successor.address. Man, I'm finding all sorts of bugs today. Some of this stuff just doesn't even make sense to me. All right. So we get the reaching constraint. And I think what we want to do actually is do this, and then we want to add a medium level IL AST break node. No, I want to do this right here. What do I do with the break nodes now? It takes a start and an address. And then what I want to do, because the successor basic block is outside the loop already, so it should be a break, and then outside the loop, it should have the successor. So maybe it is time for me to do exits. To keep track of which ones they are. Did I not bring it in? Oh, node. I did it right up there. Okay. So okay, let me look at this. Okay, so if we have multiple successors, then this is what we need to do. We need to take each of those and then do the conditions for those. All of the breaks. Everything just breaks, and then we do a sequence at the end of where each is a condition. Okay. Okay. So I think what we do then is if len successors nodes is greater than 1, then convert successor nodes to a chain of condition nodes for each successor. And then we just pick a successor, I guess. All right, so then all right, so this is self. Then next is the condition, which is going to be stew. Let's call it successor condition. And let's do this. Let's see. condition, it was start, successor. And then we just do I need to figure out. Oh no, okay, I've got nodes here. I need to check and see if successors are a region, which is going to be the case. That's also probably one of my issues. I probably leave the regions in for the stuff that should have actually been the breaks. In fact, it should be guaranteed to be a region already because I'm going backwards. We'll just do this though. And then let's see. And then false is going to be successor condition. So that way it'll just chain itself as it goes up. And that goes ahead and gets those and then here we can do if len successor nodes equals 1, then successor node. Now let's do this again. Actually, let's just move this out because if there's only one, when it goes through this loop, it'll do this for us. We don't have to do it twice. So that guarantees we have a successor node here. So then if successor node is not none, then new region equals medium level IL AST sequence node that starts with self. Actually, no, let's make this the list. No. Region nodes is going to be medium level IL AST loop node self, and what do I need again? My body and condition. Those are both going to be default, so it's just the body. So then this will be a body equals medium level IL AST sequence node self, and that is going to be list sorted list nodes. And then this will be body, and then this will be successor condition. And that way, if there's only one successor node, it will just be in the sequence. Yes. So node. Oh, no. Okay, we do this. Successor condition is not none. Successor node equals successor condition. And we'll do this too. So that's defined. And now we have our node, so we don't have any weird entries or exits. And then new region is going to equal medium else. So this is going to be this no matter what. So let's move that out of there. This is also going to be the case no matter what. So let's bring that out here. Erg. Oh wait, no, I don't need to do that. Loop node. Don't need that. This is a very long function, huh? This is all a couple hundred lines. It's just the loop one. I should put that in a function. I'll do that later. I've changed so much stuff already. Yep. I'm glad I looked back at this. All right. I don't think I'm using structure regions or convert region to sequence anymore. Am I? That's in condition and order regions. Okay, let me come up here. See how far we've gotten. I think we've gotten to step 3. So let's comment that out real quick. The linear IL view is not going to work very well right now. So let's go ahead and make sure that's at 0. It is good. And doing other stuff. So let's see what happens when we open it. I don't know if it actually does anything right now. Yeah, it's not there. Okay. We'll just have to oh. Wow. That generates. All right, none type. Where are we? 336. Current node. Why am I not setting you? Oh, right. Did I do a none on that? Because that would be very convenient. I didn't. No, that's not it. I did. Awesome. Oops. Cool. Key error. Oh, that should be get. Anywhere? Yeah, right here. I honestly think that a dictionary should just return none for anything that doesn't exist. And then you can just check if something doesn't exist. Because I'd rather just get none back. Oh shit. Did I really get that far? Shit. Looks like everything actually worked. Nope, that didn't work. Self.nodes.start. Okay. Oh, right. E31. Oh, I'm not adding stuff at some point. Oh, right. Let's try that. Look at that. That's a lot of... How many regions is it telling me I have? Because I can't read that. There are 10 regions. That's not right. There should be 2 at most. Actually, there should be 3. So that didn't work very well. Is it getting in here? I'm wondering if my in has stopped working. Yeah. Oh no, I did log info. Oh no, shit, it's getting into something. No, these are the slices. Yeah. Get rid of all that output and reaching conditions too. I don't think I need that as much anymore. Actually, no, I do need that because I was still trying to find some issues. Or maybe, did I fix that? I can't remember if I fixed the issue now. How is it getting a block right there? Oh, right. That's not gonna work. Okay. So none of those regions are in regions. $20 should be a region. Arg. Yeah, so 24. You should have found that. Okay, let's do this then. R.block. we go. Wait, what? Oh, right. Why is that not working though? Oh, I think I changed the hash. No, the hash is self.block. Both of those should make it so that the dictionary sees a node as a basic block. But whatever. I'll just do this. It'll make it easier. Oh wait, no. These are not regions. These are just these blocks. See how it works now. Wait, what the hell? Where the hell is 34 starting? There is no 34. Oh, no, here it is. Okay. Why is that getting an extra? I feel like this should actually be its own region. Since it's a loop like that. Yeah, this is where I think that should be an all up here. Where did that go? Oh, I don't want any. Yeah, I think this is supposed to be an all. Because I think this should be its own thing since everybody gets to it. Nope, that still didn't do it. No, X in regions. That's the problem. It should be should be one, it needs to be block. Why did it not? Oh, I gotta call it. Stupid. There we go. Damn it. Why are you? Oh, right. Oh, my issue is that it's coming here. If block r.block in regions, this is where I need to check it. Let's put this back to any. No, that's not going to work. Oh wait, no, that's a basic block. Yeah. All right, so I want so we want any is not none for x in self.function basic blocks if x doesn't equal bb and x doesn't equal r.block. If r.block in regions and not r has multiple constraints. I think that's what I want, because I don't want that to be part of that region. Ugh. Hey, that seemed better. Well, sort of, except it didn't. Damn it. Did I fuck something up? Oh. That's the problem. If R has multiple constraints, pass. If R.block, else if this is probably not what I want either. Yeah, that makes everything. So what I want, I think, is and R.block. Wait, no, MBB not in R block dot dominators. Alright, dot remove. Let's dot remove this whole region. Sub dot block. E43. What the hell? All right. I think the problem is that there's something that's causing it so that the the hell? Okay. What have I fucked up here? So this one is true. 34 does not have I want multiple incoming edges is what I want. Ugh, it's obvious. Why did I do that? And this is actually not going to be true if this is the case. Why is it not in the... Why is... It didn't add it, but... Oh, it's possible regions that I'm... Because I popped it. What the... Why am I moving it from here? Oh, right. If sub is not equal to R, because R has already been popped. All right. I feel like that's a better thing. We got convert to region to condition. So I need to fix convert region to condition. Yeah. I gotta fix convert region to sequence. If I even use that anymore, I don't think I do. All right, subregion. Let me see, if subregion dot type equals loop, then subregion start equals subregion dot body dot nodes dot block. Yeah, I think I always make that a sequence. If not, we'll find out, and I will. Why am I not passing this in? Because I already have it. I don't think I... Yeah. Do I even need this fucking function anymore? I don't think I do. All right, new node. This medium level IL ST condition node. Self. Condition. Start address and true. Start. And true is going to be the region. Actually, I want this to be no. That doesn't make any sense. That makes more sense. Damn it, I lost my place. Okay, there we go. Need a true. Don't want to mess this up. Okay. Let's see what we got now. Oops. Better. Made it farther. Nodes. Oh, there it is. I was about to say, where is it? Looking a little better. Maybe. You're not supposed to be in 25. Or are you? Oh, I was like, why are the numbers bigger? Okay, yeah, you know, 34. Where's 34? 34. You're supposed to be dominated by 28. You are dominated by 28. Wait. Oh, that's not making sense at all. Maybe it is working. Although 25 should be a condition. Although maybe it was going to be a condition on the next one. Where's 25? Well, I guess 25 is not in 24. Yeah. Okay, maybe this is working somewhat, maybe? What the? What the hell is it trying to remove? I definitely think that once this is actually working and I've worked the kinks out, it will be nicer and cleaner. Why is it removing that block? Does hex 22 is 34. Okay. Okay, you know what? If sub in possible region. Okay. This seems different. Twenty should add okay. 20, you have a million things. Why? Three, actually. Shit, I think that's what I'm supposed to have. But this isn't all out of order, and things are in multiple things, and that doesn't make any sense. Why are you in there? Make sure these, yeah. Don't add the block if it's. This should be in here. All right. Oops. God damn it. No, why are you adding basic blocks? You should be regions. Kind of like this one has. Why does this one have them but the other ones don't? Wait, what the hell? Oh, it's checking if the regions exist. All right, let's add more output. Oh, I only have a few more minutes to do this. Let's see. All right. Okay, that still is not right. 34 should not be adding 31. 31 should be its own thing. Okay, so why is this not working anymore? R has multiple constraints. Oh, damn it. No, I can't do this. I need to do it here. All right. Has multiple regions, so there. Adding that. Creating a region for 29. Has one thing. True. So it's not in its region. So then creating a region for 28, which is here. Checking if region 34 is. It's multiple constraints. It's in the region, so 28 should get this one. Nope. Google apparently wants to update something. Anyways, okay, so that looks correct. Tree 31 is in regions. Yeah. All right, 25. That's the problem. I am iterating over what's in possible region and popping it. What I need to be doing is iterating over regions and saying if these are in the region, then do this stuff. That's the problem. Regions in this region. No, let's do it the other way. And then I can just do and that actually means I get to pull all of this stuff out. And then we just say to make sure it's a set Don't bother about sorting it. Everything that's left gets appended. This might... I don't know why this says this here. Because that's getting done up here. Alright. Come on, give me a win. Whoops. Right before I need to go. Oops, self.pasta, did I do that? Where? Oops. Actually, you know what? I think I can just... Oops. Unhashable type. Better. Need to add a hash. Did not know I didn't have a hash on this one. Actually, I think that's enough. Shouldn't be anything else that has the same start. Still weird. Why is 16? Shouldn't be getting any of these. Should be its own sequence. Oops. Should be 18. Three. Okay, those are actually the regions they should be, but 18 and 16 should be their own things. They should not have anything in them. So why are they getting everything? And why is it not outputting anything here? Oh, right. Oops. Still? Okay. Okay, so regions in this region. Got all of this, so for all in our impossible region. I gotta stop doing that. I think I can actually import multiple times because of doing it in a function. Untype. Oh, God. Okay. You are not supposed to be there. Why is possible region still completely full? Requires multiple constraints. I don't want to continue now. I want to remove everything. So we add it to the region for this, and then we remove it. Ah, damn it. Didn't mean to close that again. Okay, so I got 16 to 18 to work. No, that doesn't work at all now. The other region is gone. What the hell? Oh, I'm deleting it. Let's go ahead and just put that up here, because we don't need it again. All right, let's see if this actually works this time. See if it gave me a different output. No, it didn't. Okay, I do have to quit. All right, it looks like my family is home, so I need to go ahead and quit it after this last run. See if we fixed it. That looks better, sort of. 25 should not be in their regions. $25 shouldn't be in both of their regions. 25 should be in this one's region, and that's it. All right, that's closer, but I've got to go now. I think we made a lot of progress on refactoring that stuff today. It looks a lot cleaner in my opinion, and probably a lot less confusing once we get a little bit farther down. So yeah, catch me next Tuesday, and we'll keep going with it. And I guess the only other thing I should announce is that I'll remind you that if you're interested in taking a course on automated reverse engineering with Binary Ninja, I'm teaching a course at Recon. If you go to recon.cx, you can find under here, under trainings, automated reverse engineering with Binary Ninja, and with me. And then you can click here for more details, read about all the cool stuff that we'll play with, and then you can click here to register down at the bottom, and then find it here and purchase some. There's still some tickets available, so the early bird I think already finished, so you've got to deal with the standard cost. So get on it now, and I hope to see you there. Anyways, I'll catch you all next week. Thanks for watching. I might stream on Sunday, maybe not because it's Mother's Day. We'll see. Have a good night, everybody.